Hello everyone, welcome to Fact Fountain. Today, we're diving into the colorful world of rainbows to uncover the secret science behind them. Stay tuned as we explore this fascinating natural phenomenon. A rainbow, that spectacular arc of colors in the sky, is more than just a beautiful sight. It's a fascinating interplay of light, water, and physics. But what exactly causes this mesmerizing phenomenon? It all starts with sunlight and rain. Sunlight, which appears white to our eyes, is actually a mixture of many different colors. When this sunlight encounters raindrops in the air, something remarkable happens. The raindrops act like tiny prisms, bending the light. Each raindrop refracts the light, splitting it into a spectrum of colors. Red, orange, yellow, green, blue, indigo, and violet, each color emerges at its own distinct angle. The result, a magnificent arc of colors that we see as a rainbow. But it's not just any arc, it's a circular one. We usually see only a part of this circle because the Earth's horizon blocks the rest. Each observer sees their own personal rainbow, uniquely created by the specific angles of the sun and the raindrops relative to their eyes. So next time you spot a rainbow, remember, you're witnessing a personal and scientific marvel, a perfect blend of light, water, and the laws of physics coming together to create a masterpiece in the sky. To truly appreciate the magic of rainbows, we need to start with the basics, the science of light. Light is more than just what brightens our day. It's a fundamental part of how we experience the world. Light, as we perceive it, is actually a tiny part of a much larger electromagnetic spectrum. This includes radio waves, microwaves, infrared radiation, visible light, ultraviolet light, X-rays, and gamma rays. What's fascinating is that visible light, the part of the spectrum we can see, consists of various colors. These colors have different wavelengths, which is why they appear distinct to us. When light travels through space, it moves in waves. And each color has a specific wavelength and frequency. Red light has the longest wavelength, while violet has the shortest. But what's really intriguing is that we don't always see these colors. When light comes from the sun or a bulb, it's called white light, which is actually a mix of all the colors in the visible spectrum. It's only when light interacts with certain objects or phenomena like water droplets in the case of a rainbow that these individual colors become visible to us. Now, let's dive deeper into the roles of refraction and reflection in creating a rainbow. It's a fascinating interplay that brings science and nature together in a beautiful display. When sunlight reaches a raindrop, it's traveling through air. But once it hits the water, it enters a different medium. This change causes the light to bend, a process known as refraction. Each light wave bends at a slightly different angle depending on its color. Red light bends the least, while violet bends the most. Inside the raindrop, the light reflects off the inner surface. This reflection changes its course, sending it back towards the air. As the light exits the droplet, it refracts again. This second refraction further separates the colors, sending them in slightly different directions. This entire process, entering, reflecting, and exiting, occurs in countless raindrops simultaneously, creating the full spectrum of colors we see in a rainbow. Interestingly, the angle at which the light is refracted and reflected is crucial. It's why we typically see rainbows when the sun is low in the sky, behind us. Each raindrop contributes only a single color to the rainbow you see. It's the collective effect of millions of droplets that forms the full arc of colors. Now, let's delve deeper into how dispersion creates the color spectrum we see in a rainbow. When sunlight enters a raindrop, it's like entering a tiny prism. Each color in the spectrum has a different wavelength. Red has the longest wavelength, and violet has the shortest. This difference in wavelength causes each color to bend at a unique angle when it passes through the water droplet. Interestingly, the colors of the rainbow always appear in the same order. This is because the angle of refraction is consistent for each color. Red is always on top because it bends the least, while violet is at the bottom, bending the most. But there's more to it. The phenomenon of total internal reflection also plays a role. Once the light refracts and separates into colors inside the droplet, it reflects off the inner surface of the droplet. This internal reflection is what sends the different colors of light out of the raindrop at various angles, creating the arc of a rainbow that we see in the sky. And here's a fascinating fact: each droplet contributes only one color to the rainbow that you see. The arc is actually a collection of light from millions of droplets, each adding a single color. So, the next time you see a rainbow, remember that you're witnessing a complex and beautiful dance of physics, involving light refraction, dispersion, and reflection, all happening in tiny raindrops. Now, let's delve into one of the most intriguing aspects of rainbows: the role of the observer. It's fascinating how our position relative to the rain and sun changes the way we see a rainbow. First, it's important to understand that rainbows are not physical objects. They cannot be approached or touched. They are optical phenomena that depend on your specific viewpoint. For a rainbow to form, the sun must be behind you, and rain must be falling in front of you. This is why rainbows often appear in the opposite part of the sky from the sun. The height of the sun in the sky also affects the appearance of the rainbow. A low sun will create a higher and more prominent arc, while a higher sun results in a lower, less visible arc. Each observer sees their own personal rainbow. If two people are standing a few meters apart, they're actually seeing two different rainbows, as the light refracts through different raindrops for each person. And what about the shape of a rainbow? We usually see a semicircle, but rainbows are actually full circles. The ground prevents us from seeing the lower half. But from high vantage points like planes, full circle rainbows can sometimes be observed. The color intensity and order also vary depending on atmospheric conditions, the purity of the air, size of the raindrops, and even the angle of the sun can make a rainbow appear brighter or more washed out. So, the next time you marvel at a rainbow, remember, your unique perspective plays a key role in its creation. It's a personal and transient piece of art, crafted by nature's intricate laws. We often think of a rainbow as just one arc of colors. But did you know there are various types of rainbows, each with its unique characteristics? Let's explore some of them. The most common type is the primary rainbow, which we often see. But sometimes, a fainter arc appears outside the primary one. This is the secondary rainbow, with its colors reversed due to double reflection of sunlight inside the water droplets. Look closely next time, you might spot fainter pastel-colored bands on the inner edge of the primary rainbow. These are supernumerary rainbows, created by the interference of light waves. Ever seen a rainbow in shades of red? Monochrome rainbows occur just after sunset or before sunrise, with red being the most dominant color due to the scattering of light. Reflection rainbows are intriguing. They form when sunlight reflects off a water body before refracting through the raindrops, creating a secondary arc. And let's not forget moonbows, nighttime rainbows formed by moonlight. These are much rarer and often appear white to our eyes due to their low light intensity. Throughout history, rainbows have been revered in various cultures, often seen as mystical or divine signs. Let's explore some fascinating examples from around the world. In Greek mythology, the rainbow was considered a path made by the messenger Iris, linking us to the gods. This myth reflects the awe and reverence ancient cultures felt towards rainbows. For the Norse, the rainbow, known as Bifrost, was a bridge connecting Earth to Asgard, the realm of the gods. Similarly, in Hindu mythology, the rainbow is called Indradhanush, meaning the bow of Indra, the god of thunder and war. Indigenous cultures also have rich interpretations. Australian Aboriginals view the rainbow as a serpentine creator god, symbolizing life and the shaping of the landscape. Today, rainbows have taken on new meanings, most notably. The rainbow flag is a symbol of LGBTQ+ pride and diversity, representing hope and acceptance. In literature, rainbows have been symbols of hope and promise. The Bible's story of Noah's Ark, for instance, presents the rainbow as a sign of God's covenant with humanity. In various African cultures, rainbows are associated with good and bad omens, from messages of the gods to symbols of life and growth. This rich tapestry of interpretations and beliefs shows us how a simple, natural phenomenon can take on profound and diverse meanings across different cultures and times. The science behind rainbows is not just a fascinating natural phenomenon. It has practical applications in our daily lives and various scientific fields. In meteorology, the appearance of a rainbow can indicate the size and type of raindrops in the atmosphere, which helps in weather prediction. In optics, understanding how light refracts is crucial. This knowledge is applied in designing lenses, cameras, and even correcting vision through glasses and contact lenses. Rainbows can also be used in environmental monitoring. By analyzing the light spectrum in a rainbow, scientists can detect pollutants and other atmospheric conditions. The vibrant colors of rainbows have inspired artists and designers. The principles of light dispersion are used in creating color palettes and lighting effects in art and interior design. So, the rainbow, while a marvel to behold in the sky, is also a key to unlocking many scientific and artistic doors. Its influence stretches far beyond its aesthetic appeal.